Alright guys, so your homework for tonight, you go back a page, is page 102 of your student journal exploration 2. We're going to do A through C, and this is not my questions. These are the big idea math questions, so all the work is credited to them. These problems is credited to them. Alright, so the first question is called rotating a triangle in the coordinate plane. So question A says the point XY is rotated 90 degrees counterclockwise about the origin. Write a rule to determine the coordinates of the image. Okay, so first we need to see what this question is asking us. It's telling us to write a rule to determine the coordinates of the image, and the point is rotated 90 degrees counterclockwise about the origin. So they're telling me how far I'm going, the direction I'm going, and around what point. I'm going to show you a little way another teacher taught me to memorize these rules. And of course you can always use a chart from class, but you need to make sure you know these rules for rotations about the origin. Alright, so we start with 0, we start with 90, and then this here is 180, this here is 270, and around here is back to 0 and 360. So 0 and 360 are the same spots. Alright, so you start out at the 0 and 360 at x comma y. And then when you rotate it to the right, you get y minus xy. The x is opposite. And then here, you're going to keep the coordinates the same, except you're just going to change their signs. And then here, you're going to switch x and y again, where the y is negative. Okay, so that's the coordinates you can write for going clockwise. Now clockwise means to turn to the right. If we go counterclockwise, then we're going this way. We're going to the left. So we're turning to the left for counterclockwise. So when you go counterclockwise, then we're going to say, and I'm going to write these in red, we're going to say 90. We're going to say 180 is the same spot, 270, and 360 goes up here at the top. So that's for counterclockwise. The stuff in with the x and y does not change. That's just one way to memorize this, and you'll always get it right. So the rule for rotating counterclockwise about the origin, that means we go to the left. We're going to turn to the left about the origin. That means the rule tells you, which is right here, to make the y negative, switch x and y, and make the y negative. So you switch x and y and make the y negative. Alright, now it says, use the rule you wrote in part A to rotate triangle ABC 90 degrees counterclockwise about the origin. What are the coordinates of the vertices of the image triangle A prime, B prime, C prime? Alright, so here's what I'm going to do. I'm going to first go and write all the points, and then I'm going to follow my rule. I'm going to write the points of the pre-image, and this is 1, 2, 3. So this is 0, 3. B would be 1, 2, 3, 4. 4 and 5. And C would be 1, 2, 3, 3, and negative 3. Alright, so now we're going to write what the rule says to do. So the rule says to switch x and y. This is x and this is y, and then make the y negative. So negative 3, 0. I'm going to do the same thing for the rule here. Negative 5, 4, and these are my primes, and my C prime would be 3, positive 3. And all I did was switch x and y and then took the opposite of the y. Okay? And that was going to the left. So now let me go and plot these points. So negative 3, 0, negative 5, and positive 4. 1, 2, 3, 4. So this is A prime, B prime, and then C prime with 3, negative, oh I'm bad, 3 and positive 3, so 3, 1, 2, and 3, and that is my C prime. And this would be rotating that figure 90 degrees clockwise. If you rotate that figure 90 degrees, I'm sorry, counterclockwise, that means to turn the paper, or you're turning the figure to its left about the origin. Okay, if we was going clockwise, we turn it to the right about the origin. Okay, so next it says draw triangle A prime, B prime, C prime, and are its side lengths the same as those of A prime, A, B, and C? Justify your answers. And we're going to say yes, because a rotation, well, we already drew the triangle in blue. A rotation is a rigid transformation. And then we'll get in a little later on how we can prove this for sure. But we definitely know this is a, if I line the primes up with the original, if I rotate it back around and line it back up to the original, they would be exactly the same. The side lengths would be the same and the angles would be the same. And rigid transformations preserve the length of the side and preserve the angles of the corresponding, well, it preserves the corresponding angles. Alrighty, I think, let me see if there's any more. That is it for today, guys. See you on tomorrow. Bye.